All right, ladies and gentlemen, I want you to go ahead and copy this down. Teachers, if you would like to pause it for about 30 seconds so that the students can copy this down. All right, so you have three triangles and you have four quadrants at the bottom. We're going to go ahead and start with the triangles at the top. Just as we have taught you, make sure to put the variables inside the triangles. That way we know if we need to solve for any other variable. So mass is over volume. So just like you see it, that's how it's going to be seen in the triangle. Mass is over volume. This divides and the vertical line multiplies. So for solving for m, we're going to multiply the density times volume. If we're looking for volume, then that means that mass is going to divide over density. Next one, speed equals distance over time. Distance is over time, so distance is over time. If we're solving for distance, we're going to multiply speed times time. If we're solving for time, then that means we're going to divide distance divided by speed. Last but not least, force equals mass times acceleration. If mass is multiplying times acceleration, then those two go at the bottom. If we're looking for mass, we're going to divide force divided by acceleration. If we're looking for acceleration, then force divided by mass. Now let's go ahead and start with the plant cells. Here we have an energy pyramid. And the energy pyramid, it always starts off with the producers. 10% of the energy is passed down from one trophic level to the other. So you have your primary consumers, which are herbivores. You have your secondary consumers, carnivores or omnivores, and tertiary consumers. There are three differences that plant cells have versus animal cells. First of all, they have a cell wall. Second, they have chloroplast. And third but not least, large vacuole. That does not mean that an animal does not have a vacuole. It's just smaller. Then you have your three laws of motion. First law is law of inertia. On the day of the test, you can actually write out the whole thing. An object in motion will stay in motion. An object at rest will stay at rest until an unbalanced force acts on it. Second law of motion, we go back to force equals mass times acceleration. We want something to go faster. You might want to reduce the amount of mass and increase the amount of force. And this one is called the law of acceleration. Last but not least, you have the third law of motion, which is the law of action-reaction. For every action, there is an equal and opposite reaction. And we have the bottom part. Here we have a time distance graph. So just like in math, x, y, time is being measured on the x-axis, distance is being measured in the y-axis. So if you see a slope going up, that means that it's constant, C for constant. If you see a line that's horizontal, that means it's at rest, stationary, or that it's stopped. If you see a line going back to the x, that means that it's returning. The reason why I put the numbers 10 and 5, so let's say this is 5 seconds and this is 10 meters. We go back to, if we want to solve for speed, speed equals distance over time. That means that the distance was 10 and the time at this specific point was 5. 10 divided by 5 is 2 meters per second. Then we have in our last section plate boundaries. Here we're going to use arrows to represent the movements. between these plate boundaries. There are two types of convergent boundaries. There's one that subducts under the other. Usually it's going to be the oceanic plate because it's denser. Continental plate will stay at the top. This will produce ocean trenches. So I'm going to put ocean trenches. There's another type of convergent boundary, but they buckle up and produce your highest, oops, it's supposed to be an arrow. They produce your highest mountains. Divergent boundary, divergent, divide, divorce, separate. If it's on land, it's going to be a rift valley. If it's in the middle of the ocean, it's going to be in a mid-ocean ridge. So rift valley or mid-ocean ridge. Transform boundaries, they slide past each other. So the San Andreas fault line in California looks like, and it creates fault lines. And for all of these, it's going to, any type of movement, they're going to have, you're going to feel an earthquake. We're going to move on to the bottom part or the back part of your paper. Go ahead and take a minute to write this down. Teachers, if you'd like to pause, go ahead and do so. All right, so this is where we're going to focus on elements and compounds. This was at the very beginning of the year in first semester. So you have chemical formulas, and in order to remember what order the chemical formula lands on, just remember RAP. So we're going to zoom in there. R stands for reactants. A stands for arrow, or the more appropriate word is yields, and P is for products. So we have this chemical formula H4 plus O2 yields to 2H2. If we want this to follow the law of conservation of mass, it means that you need to have the same amount of atoms per element on both sides. So here we have two elements, one being hydrogen, the other one being oxygen. The subscript here tells us that there are 4 hydrogen atoms, 2 for oxygen. On this other side, we have a coefficient. We have to multiply times anything that's behind it. For hydrogen, oxygen, we're going to multiply 2 times the subscript of 2. Remember your invisible 1 next to the oxygen. 2 times 1 is 2. 2 times 2 is 4. So then we verify. 4 hydrogen atoms on both sides? Yes. 2 oxygen atoms on both sides? Yes. So this follows the law of conservation of mass. Mass cannot be created or destroyed. So if we add these, we have 6 atoms. Then there should also be 6 atoms on the product side. Remember your coefficient? It gives you the number of molecules. So right here, we're going to write the word molecules. Oops. Subscripts, it gives you the number of atoms. That brings us to, if we have a chemical formula, that means that there is a chemical reaction. So we go to our acronym, country girls like their phone on. C stands for color change. Again, that says color change, just in case you don't understand it. G stands for gas. L stands for light. There are 2 types of temperature changes. That's why one says endo and exo, endothermic. The other one is exothermic. Endothermic is when the temperature drops, exothermic is when the temperature rises. P is for precipitate. O is for odor. Now we go to elements versus compounds. Remember, if it's just one atom, such as hydrogen, then that's an element. If it's the oxygen that we breathe with two atoms in the molecule, that's still an element. It becomes a compound when you have two different types of elements, such as H2O. That's supposed to be an H. Let me erase that. H2O. Or C6H12O6. The sugar that plants have, that is also a compound. All right, so I'm gonna make this a little bit larger, and we're gonna make sure we finish this last part on the periodic table. 90% of your periodic tables are composed of metals, and you're gonna find them on the left-hand side of the periodic table. You're gonna remember your metalloids. We're gonna write that down at the bottom. It has a ladder here, so when you're taking the test, sorry about that. When you're taking the test, just look at your ladder and you're gonna literally shade it with your pencil. 1, 1, 2, 2, 2. 1, 1, 2, 2, 2. That way you can remember which specific elements are actually metalloids. And last but not least, we have everything that's on the right hand side are going to be your non-metals. So I'm gonna put this right here. And that's it. Make sure you do this in the very beginning of when you start on the STAAR test. And good luck.